Today we look at the topic quartiles and interquartile range, and we look at it by way of example. So I have this, I'm just going to write an arbitrary set of data. I have this set of data, 5, I have 10, 6, 15, I have a 7, another 10, I have 12, 8, 9, I have another 10, and I have a 13. So what I'm going to try to do is to find the quartiles and the interquartile range of this arbitrary set of data. And I'm going to use two approaches quickly by example. The first approach is the approach I name first approach. Is the approach I'm going to call it I'm going to call the approach the median approach. The median approach. The median approach. So let me quickly explain what quartiles are. Quartiles are numbers that cut a set of data into 4 equal parts. The set of data, when shared into 4 equal parts, the number where the first part that is greater than 25% stops, that is the first quartile, and we call it Q1. So we have what we call the Q1, we have what we call the Q2, and what we call the Q3. So the Q1 is the quartile, that is the first number, or the number that is greater than 25% of the data when arranged in order. The Q2 is the number that is greater than 50% of the set of data when arranged in order, while Q3 is the number that is greater than 75% of the data when arranged in order. So I'm going to quickly use the median approach to do that. So by doing the median approach, we will discover the first thing we need to do, if you remember, if you have not seen the mean median mode video, I charge you to click on the link in the description below, or click in the video that is showing above to watch the video mean median mode. It's a very simple and very interesting. So I'll quickly find the median of the data set, because in the median approach we can view the Q1 as the median of the lower half of data set, while the Q2 is the median of the entire data set, and then Q3 is the median of the upper half of the data set. So that means we're going to have to find Q2 first. Note that Q2 is the median of the data set. So I'm going to quickly do that. So I write out the number again, and then I arrange them in proper order. 5, 6, 7, 8, 9, 10. I think I have 10 in 3 places. 10, 10. Then I have a 12, I have a 13, and then I have a 15. So looking at this, you discover that if we decide to cut this number into two equal halves, we can count from the lower half 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 in number. So that means we are going to have 1, 2, 3, 4, 5. So 5 numbers in the lower half and 5 numbers in the upper half, and then in the middle we have 10. Therefore, we can say median of this number is equal to 10, and that is our Q2. That's our Q2. So for Q1, we look at the lower half. And then in the lower half we have 5, 6, 7, 8, and 9. So to find the median of this lower half group, we have 2 numbers to the lower half and 2 numbers in the upper half, and in the middle we have 7. Therefore, our Q1, which is the first quartile, is going to be equals to 7. In the same vein, the upper half we have numbers 10, 10, 12, 13, and 15. And to divide them into 2 equal parts, we have 2 numbers to the left and 2 numbers to the right, and we have 12 in the middle. Therefore, Q3 is equal to 12. And then, having gotten Q1, Q2, Q3, we can find our interquartile range, and that is simply given by the difference between Q3 and Q1. Therefore, for this data set, our Q interquartile range is going to be equals to Q3, which is 12, minus 7, which is equal to 5. That is the first approach. Straight to the second approach, we have the formula approach, and we have the formulas here. For Q1, we have 1 over 4 multiplied by n plus 1 term. So the term in the 1 over 4 multiplied by n plus 1 term is the Q1, that is the first quartile, while the third quartile is 3 over 4 n plus 1 term. So quickly, let us work that out. For the first quartile, we have 1 over 4 into, remember our n is 11, so we have 11 plus 1, so we have this equals 1 over 4 multiplied by 12. This will give us 1 over 4 times 12 over 1, and this will be equals to 12 over 4. So you divide this will give you 3, and that means the third term in the data set is going to be our first quartile. So if you look at them in the arranged order, you say first, second, third. So you have third term, which is equals to 7, and true to it, our Q1 is 7. So let's go back to say Q1, the third term, is equal to 7. Therefore, Q1 is equal to 7. The same thing for Q3 is going to be 3 over 4 into 11 plus 1, and that is 3 over 4 into 12. Writing it out, we have 3 over 4 multiplied by 12 over 1, and that will give us 36 over 4, and that we have the 9th term. Going back, this is the 3rd, the 4th, the 5th, the 6th, 7th, 8th, and the 9th term, and that is 12. So the 9th term is equals to 12. Therefore, Q3 is equals to 12. Interquartile range again, Q3 minus Q1 is going to be 12 minus 7 equals 5. Thank you.